Hello, this is Ms. DB, and today we are going to learn more about quadratic functions. We will be discussing Chapter 5, Section 2 on properties of quadratic functions in standard form. We will want to do a lot today. We're going to define, identify, and graph quadratic functions, also figure out if we have a maximum or a minimum in our problem, and then use those to solve problems as well. So when you transform quadratic functions from the previous lesson, we saw that if we reflect the parent function across the y-axis, it's exactly the same. So that means that the quadratic function of f of x equals x squared, or y equals x squared, is exactly the same as g of x equals parentheses negative x and then squared. Because if you take a negative number and square it, you get a positive number. So it's the same exact thing. This shows that parabolas are symmetric. The axis of symmetry is the line that cuts the parabola exactly in half into two congruent pieces. It goes through the vertex. So you can see if the vertex is HK, the line of symmetry, this red dashed line here, would cut that into two congruent pieces. The axis of symmetry is a vertical line, and we know that vertical lines are always of the equation x equals and then the x-coordinate that the line goes through. So if the vertex is hk, where h is the x-coordinate and k is the y-coordinate, then the equation of the axis of symmetry would be x equals h. Okay, here is a function. Here, let me just go back to this real quick. The axis of symmetry was x equals 1. Yep, that matches. The y-intercept is 5. I didn't mention that. All right, here's another example. This is negative x squared minus 2x plus 3. So does it open upward or downward? Downward, because a is negative 1. This would be negative 1. The axis of symmetry, we have the equation x equals negative b over 2a. b is negative 2 and a is negative 1, so you substitute those in and you get the axis of symmetry as x equals negative 1. Then we find the vertex. We already know the x-coordinate of the vertex is negative 1, so we plug negative 1 into the function and we get 4. So the vertex then is at negative 1, 4. The y-intercept, that's the easiest part, is just 3. And now we can put those things together to graph the function. Again, you can use your sketch pad or your graphing calculator to help you do this. So here's the sketch of the axis of symmetry at x equals negative 1. We know that the vertex was at negative 1, what was the vertex? Negative 1, 4, sorry. Negative 1, 4. So that would be here. We know it opens downward. We know that the y-intercept is at 3, so this side has to be matching. And then you would just try to, it's hard to draw this with a pen on the computer, but try to draw a nice smooth curve that goes through those points. And check it. Okay, here's an example from your worksheet. First, I'm going to put in what A, B, and C are so I can answer the rest of this without having to keep going back. The graph opens, well, A is positive, so it's going to open upward. The axis of symmetry is x equals negative, and then B is negative 4. 2 times A would just be 2 times 1. So we simplify this, and we'll get 2. So the axis of symmetry is x equals 2. I'm going to put that on here right now. Here's my axis of symmetry at x equals 2. Because 4 divided by 2 is 2. Find the y value of the vertex, so you would take 2 and plug it back in. So we'd have 4 minus 8 plus 3, and you'll finish that and you'll get the y value. So then your vertex will be, let's see, we already know it's going to be 2, and then you just have to find the other part. And then that's the same as number 8 or number 9. Oh, I guess 8 just asks you to find the y value. 9 asks you to actually write the whole vertex. So in 9 or in 8, you're just asking for what is the y value. And then the y-intercept is really easy. You just look at the c, and that's 3, so the y-intercept is 3. And then you'll sketch this. You'll need to put your vertex on here, whatever you find for that. And remember, it's going to open upwards, so it's going to be something like this. There's another example. In this one, A is negative 2, so it's going to open downwards. But you'll just go through and fill each of these parts in. This is just looking for the y-coordinate of the intercept. The vertex coordinate. That's what 14 is asking you to find. And 15 is the vertex, and 16 is y-intercept, which is negative 2. I can tell that one easily. All right, if you substitute any real value of x into a quadratic equation, you get a real number. So the domain of any quadratic function is all real numbers. The range depends on its vertex and the direction the parabola opens, but your domain is always going to be all real numbers. Here we have an example of an opening upwards. Of course, the domain is all real numbers. And the range in this one is going to be all the y values greater than or equal to whatever this number is, which is the y coordinate of the vertex. If it's opening downward, the domain is still the same, all real numbers. What changes is the range is going to be y is less than or equal to the y coordinate of the vertex. So in the first example, this is a minimum point. In the second example, this is a maximum point. You need to know your minimum and maximum a lot of times in problems. So the minimum or maximum is the y value of the vertex. It's not the vertex itself, just the y value.